So by right, last video we should stop already, but I thought that I should explain to you why we have to integrate twice. Why we cannot integrate twice for pipe system. As I said earlier, non-pipe system you integrate twice first and then you apply boundary condition. While for pipe system it's a different way. You integrate once, you apply the first boundary conditions where everything has to be equals to 0. Okay, when you apply boundary conditions, you have to apply everything is equals to 0. So, and then you will integrate again, and then you apply second boundary conditions. So this video will explain why we cannot use what we use for the non-pipe system, that is integrate twice. Okay. So when you integrate it twice, you have this formula over here, right? This is exactly the form of when you integrate one time, you have this equation. You integrate second time, okay, this is what it is, right? It's exactly the same. Okay, if you don't trust me, it's okay. I just want to convey the message that they are not the same. When r is equals to 0, so this repeat again. This is the second integration. So r is equals to 0, u is equals to u. Okay, which is when r is equals to 0. Okay, the velocity of the fluid is the fastest, which is equals to u, capital U. So when we sub it in, okay, we see that d is equals to u, right? Nonetheless, if you sub in r is equals to r, u is equals to 0, right? So this is the first boundary condition. You found that d is equals to u, and then so this is the second integrated. So this is the second integrated equation. I found d is equals to u, and therefore I just simply change d equals to u. So these are the same equation, just I change d is equals to u, that's all. Okay, and then when r is equals to the capital R, u is equals to 0. So I sub this equation with r, so this small r will become the capital R, while this small r square will become the r square. So and I rearrange, you have C. Okay, you're just trying to solve for C, that's all. Okay, and then this becomes a little hairy. Okay, so this is the very general one for when you integrate it twice. So I'll just bring it down. So since you know your C already, okay, I'll just put it over here. Okay, maybe I should draw a boundary so you can know where am I. So C is actually this one. Okay, this is C. So yeah, so the rest I keep the same. So C is over here. And then D is equals to U. I do a few rearrangement. Okay, don't doubt. Okay, I repeated a lot of times, so it should be correct. End up I have a equation like this. Maybe I should go through lah. So as you can see, C is equals to this, right? I just cancel away the R. Maybe I shouldn't cancel it. I multiply the R first. So the small r when multiplying in, because this portion over here, this portion, so this is just multiplying with r and ur. So this is minus ur divided by r, right? So it's the same thing. I only did that, and then at this portion I cancel away all the unnecessary stuff. I don't cancel. I didn't cancel, I just leave it there. I just factorize. I factorize out this portion over here and this portion over here. So when I factorize out, I have this thing. So this is r squared minus r squared over r. And then I can cancel away, I have r squared minus r over here. And then this is minus ur over r. Okay, all the ways the same. And then this portion here, since we have a common term, you can factorize out the u, and you have what do we have? You have actually it's oh yeah, I have my mistake. Lucky I go through. Yeah, we have like that, right? U and r over r plus 1. Okay. So how does this equation different from this equation? Okay, let's do it out. Okay. So let's bring it over here. The difference is that you have a one more term to find. Okay. This equation you only have nu, the pressure, the x, the r, small r, and the capital R. Right? However, this thing we have all same as this, but we have capital U, okay, which is the full speed. So we have one more variable to find. On top of it, I can't confirm that this portion over here is the same as this portion, okay, because I don't have the value, okay, but more or less this should be the safest one, okay, by first integrating one time, and then you apply boundary condition, integrate again, and then apply second boundary condition. So I'll just do a next video for summary, and then I'll just call it a day. So I'll see you in the next video. Bye bye.